Hi, in this video I will be going over the answers to the Unit 1 Test 2 review for Math 2. So for number 1, we are asked to determine if the real numbers are rational or irrational and explain. So keep in mind that this is a 2-point question. Each one of these are 2 points. 1 for answering if it's rational or irrational, and 1 point for the explanation. We have the square root of 4 over 9. That is 2 over 3. And because it is the ratio of two integers, it is rational. We can type that in our calculators if we like, simply by typing in the square root of 4/9. As for the explanation, I would put ratio of two integers. And keep in mind, an integer is any positive or negative whole number, like -2 or -1. These numbers we typically see on a number line like the one above the board. All right, next for B, we have 3.172 with an ellipsis. This here means it goes on and on. So this is non-terminating. We know that because of the ellipsis. We also notice that it does not repeat. 1, 7, and 2 do not have a repeating pattern, so we can say non-terminating and non-repeating. Both of these terms define a number that is irrational. Also, we could not turn this into a ratio of two integers. So if you would prefer to explain it is not the ratio of two integers, that would be fine as well. For C, the square root of 72, that is a non-perfect square. Square roots of non-perfect squares are irrational. Feel free to put it in your calculator and you'll see that. So I'll put non-perfect square roots. Non-perfect square root. Or you can explain that as a decimal, that it is non-terminating and non-repeating. For D, we have 2.93 with a vinculum over the top. This indicates that the 9-3 will continue to repeat. It'll go on and on in that pattern. So it is a rational number because it is a repeating decimal. For number 2, it says use any number you choose to fill in the blank to make each statement true. You can only use the numbers you choose once. So at this time I have an irrational number and I need to add a number to make an irrational sum. So there really isn't a whole lot you can do wrong here except pick a number like the opposite of the square root of 11. That is the only way we can turn the sum of two irrational numbers into a rational. So it can be a number like 3, it could be pi, it could be the square root of 5, basically any number except, so I'll put any number except the opposite of the square root of 11. Because if you combine the square root of 11 and the opposite of the square root of 11, we get 0, which makes it rational. So any number that you choose would be correct except for the opposite of square root of 11. For this one here, the square root of 5 is an irrational number, and we want to multiply by a number to get an irrational. So it is your choice what you could pick. We could choose any number except don't use the same number we chose here for 3. If I chose pi here, that would be an irrational number. Remember, your exceptions are a number that would create a perfect square root. So if we multiplied the square root of 5 times the square root of 5, because that would give us the square root of 25, which equals 5, and therefore be rational. And we can't multiply by 0, because if we multiply by 0, it will turn rational. So I'll say there, any number except the square root of 5, or 0. And there might be some other numbers that we could multiply that by that would create a perfect square, but just keep that in mind. For number 3 here, you've got the square root of 3, also irrational, and we want you to add a number to make it irrational, or excuse me, a rational number. So remember how over here I said the square root of 11 plus the negative square root of 11 would equal 0? That's what we want to happen here. So we want to use the opposite of the square root of 3, which is negative square root of 3. If we combine those together, we get 0, which is a rational number. So this is very specific. You have to have the opposite here to make it rational. For number 5, the square root of 2, we could have a couple different options. If we multiply by the square root of 2, that would give us the square root of 4, which equals 2. We could take the square root of 2 and multiply by the square root of 8, which would give us the square root of 16, which equals 4. So there may be multiple options, but one of the easiest to remember is simply that if we multiply by 0, we get 0. So that's a good safe one to remember there. So these are very specific. We need here the opposite of this irrational number to add to get a rational number. Number 5, we can either multiply by a irrational square root, a non-perfect square root, to end up with a product that is a perfect square root so that it turns rational. Or we can just remember to multiply by 0. 0 is probably the easiest to remember. Over here, you can choose almost any number. All right, for number 6, common mistake students made on the last test, they weren't distributing your minus sign. So a couple different things you can do. You can remember to remember that the opposite of 5x squared is positive 5x squared, and I recommend putting it under its like term over here. The opposite of subtract 2x is add 2x. Put it under its like term here. The opposite of add 3 is subtract 3. And then we can combine our like terms vertically. 8x squared plus 7x minus 10. Now, you also may prefer to change your minus sign to a plus sign and then change the signs of the polynomial that follows. And if you choose to do it that way, that's fine also. Oh, I made a mistake. My apologies. I said here that the opposite of 5x squared is 5x squared, but it's actually negative 5x squared. I'm sorry about that. The opposite of minus 2x was plus 2x, and the opposite of add 3 is subtract 3. So my apologies. It's just that this first term should have been subtract 2x squared or negative 2x squared. Sorry about that. But again, if you change your signs here and then combine like terms, that is fine as well. Just be careful about your signs. And remember, you can do 1 store as x in your calculator, type in your original problem, and type in your answer, and your output value should match. You actually can use that method of checking for 6, 7, and 8 because these are all polynomial operations. For number 7, we have a quantity squared. Please remember that we cannot just distribute exponents. It means that we need to write the quantity 2x minus 6 twice. So we are multiplying it by itself. When you double distribute, 2x times 2x is 4x squared. 2x times negative 6 is negative 12x. Negative 6 times 2x is negative 12x. And negative 6 times negative 6 is positive 36. Then identify like terms here in the middle. Bring your first term down. Combine these two. Please use a calculator unless you're really good with combining integers. Negative 12 minus 12 is negative 24x. And then we just bring down the plus 36. Again, check that answer. 1 store is x. And then type your problem in exactly as you see it. And then your answer in, and it should match. Number 8, we have a binomial times a trinomial. My recommendation is to use a box. If you prefer distributing and stacking, that's fine as well. We're not going to be picky about the method you use. We just want to see a correct product. All right, so we're going to fill in our boxes by multiplying the terms in the top by the side. So x squared times x gives us 3x's, so x cubed. That's the product of 3 x's. X times negative 2x is negative 2x squared. It is super important to keep your signs correct. X times 7 is 7x, and x squared times 5 is 5x squared. 5 times negative 2x, negative 10x, and 5 times 7, 35. At this point, we notice that we should have, please keep this in mind, you should have like terms diagonally here and here because we have x squared terms, and here we have x to the first terms. Now, be careful that you pay attention to your signs. When we write our final answer, we take this term up here with the highest degree, x cubed, and write it first. Combine our x squared terms. Keep in mind that this is 5 minus 2, which is 3. 3 is positive, so we're putting plus 3x squared. Notice we are not changing its exponent. Now we have negative 10x plus 7x, which is, type that in your calculator if you need to, negative 10 plus 7 gives us negative 3x, and positive 35 means we put plus 35. All signs need to be written just like this. Okay, we've got to have the plus signs and the minus signs, and we should have x cubed, then x squared, then x to the understood first power, then a constant. Okay. Next, we're going to be talking about simplifying each expression with our laws of exponents.